4 years ago, we had a very tiny pod, like one of those, and that was all of Microsoft's presence at HANNOVER MESSE. Today, we have one of the largest booths, or the largest booth in Hall 7, which shows the progression of IT and OT convergence. And 4 years ago, we were trying to sell CRM, which we still do, which is an important component, obviously. And kind of more on the, really truly on the IT side. 3 years ago, we presented our IoT suite as something that people could potentially go and build something on. Last year, we presented our integration with OPC UA. And this year, at our booth next door in Hall 7, you can actually see a lot of customer showcases that are using that technology today already on the OT side, on the operational technology side, to go and integrate their systems and to also funnel information into IT, get information out of IT. So we have come a long way already, but it's a long journey, and we're at a point where it's actually time to celebrate some achievements that we have made all together, specifically in the collaboration with OPC, with the OPC Foundation. And so I'm going to talk some about that, but then talk about the next 4, 5, 6 years that we have as an industry, or as industries, to come together and special things to solve. So I'll talk about this. So my name is Clemens. I'm an architect at Microsoft. The team is in Redmond. I live in Germany. I'm a member of the OPC Foundation's UA working group, as well as of the Technical Advisory Committee. And in OASIS Open, the standardization organization, I'm also on the technical committee for the AMQP messaging standard, and I also advise our work in the MQTT messaging standard. So a lot of the acronyms that you've seen all over this trade show now, specifically this time, are things that I'm directly involved in. So what I'm going to talk about today is I'm going to give you some answers, mostly things that we've achieved, and then I have a lot of questions. I'm going to raise a lot of questions. And I will not claim that I have answers for many or even any of those, because we have a lot of stuff that we have to do as industries to come together and solve. And we've now scratched the surface of the challenges that we have. So where we are, we have an OPC PubSub standard that I'll talk about and that I'll explain. But the challenges that will be, how do we establish joint understanding about data? How do we express data in a way that we can understand it across the divide? And how do we solve what I call the nested doll problem, which I will also call the sensor dilemma a little bit later, of data ownership and trust. And these are all things that we need to go and address. OT and IT means collaboration and will continue to mean collaboration because we have different skill sets across that divide. When we look at OT, the primary objectives that operations technology developers, so I specifically talk about the engineers here, they want to have safe, precise, reliable, predictable operation of physical equipment. Folks on the IT side need secure, reliable, and highly available operations of data storage and processing systems, which are different things. The tool chains are different. The development processes are necessarily different because if you build physical equipment, your engineering cycle is very different than if you just build software. So there are different objectives, constraints, skills, tools, process, and scope across OT and IT, and that will continue to be like this. And it's impossible for someone who's really good at integrating local systems to also become really good at being a cloud developer, because that doesn't fit into one head. It's just really hard on both sides. So we'll have to establish mechanisms for exchanging information and exchanging notion of semantics between those different populations of engineers who are collaborating and will collaborate across this. There will be no single population of people who are bringing this all together, because we have specializations around the edges which are necessary, and you can't fit it all into one head, and you also can't fit it into one work life. So let's talk about OPC UA for a moment. OPC UA, part 14 of the specification, I'm gonna have a text slide about that too, addresses specifically the new PubSub specification, addresses is a gateway function between the OT space and the IT space, a particular part of that. I have this, and allows you to integrate with a wide variety of systems at the back using standardized protocols. So I have that's annotated. Oh, okay. So we'll start from here. OPC UA has a notion of properties, information bits, that reflect the state of physical components or reflect their configuration settings. Those are all mapped into an address space. And this address space is how you can go and identify all of them. This is OPC standard as it has been, as it now becomes more popular, which means you can now create a logical image in a standardized fashion of the underlying device. You can now go and take and do queries into this address space to create records. And these are current information about the state of that device, and you can do this based on a change, or you can do this based on timing. And then you can write those out into a writer, a thing that goes and takes this abstract notion of a message and then formats it for the wire and then it writes it out to the wire to some IT system. That's the work that we've done in the last 3 years, kind of trying to figure out how do we take this notion of physical systems, how do we create an abstraction over it, and how do we take that abstraction, make it digestible for people who work in IT and who are sitting kind of at the top of this, in the clouds, and are trying to work on this. So that's the substance of the OPC UA PubSub extensions is that. So it's part 14 of the OPC UA specification. It's currently in release candidate form. The OPC Foundation takes commentary on that specification, but there is already plenty of implementation going on around this. And when you go with open eyes through these halls and you see OPC UA and there's a arrow pointing up in the cloud, and you see MQTT and AMQP on it, that is this. That is already either the implemented PubSub specification or is foreshadowing of that PubSub specification in some other form. And you can see this at the Microsoft booth. You can see this even over at AWS in that tent. And you can see this over in Hall 9, Hall 7, and even over in the robots hall. And everybody's kind of following the same patterns. The PubSub specification covers two core aspects: local communication, local publish-subscribe communication, which means you have events that you need to make known to other devices that are sitting in the same shop floor environment. That happens using UDP as a base protocol, and there's companion specs that may also make it possible using DDS. And there's discussions that we have with, we from Microsoft have in a bilateral fashion with other folks, IT folks in the industry, who I won't name, to also fit some other protocols into that. OPC UA is not a protocol, it's a tent, and it's an architecture. And we can plug AMQP in there, we can plug a DDS in there, we can plug MQTT in there, we can plug all the protocols in there which fit and which are best fit for a particular purpose. The local communication, UDP, and with a companion spec, DDS, for instance, and also time-sensitive networking as the newest initiative that's being driven so that you can actually do hard real-time using that PubSub mechanism. What I'm going to talk more for the remaining time on is the integration with message-oriented middleware, the integration with back-end systems, like the Azure IoT Hub, so things that sit in the cloud, but just as well, infrastructures that sit on premises. Because in very many cases, as I'll show you on the picture, these are all message-driven and not necessarily just pure networking infrastructures. And I'll explain the difference. The battery on this is weak. So there's the sensor dilemma. The sensor dilemma or the nested doll dilemma of OT is everybody, and you walk around this trade fair, everybody wants to offer predictive maintenance, monitoring of equipment, sometimes operations of equipment. Everybody has a grand vision, and you walk around, and then you have companies that we also work with in the OPC Foundation. I'll just, one example is SICK. Those folks always have boxes built around their products that prevent the data from flowing out. Everybody wants to go and offer these things, but the reality is, and this is a different picture of this, the different picture is here. Whoever owns the biggest box today gets to say what data flows where. And the typical answer for everybody inside of that box is no. So you walk to a major plant operator as a component, let's say a machine manufacturer with some heft, like robots. And you go and say, and I mean like very large arm robots. And you walk up to the plant manufacturer and say, I want to have data out of your plant. The standard answer is going to be no, because I have the biggest box. You set up a plant, let's say you set up a bottling plant. The bottling plant is now under contract from a major beverage maker. The plant operator may say yes, but the beverage maker will say no. So there's some significant issues in cross-organizational trust. There's this giant amount of worry, and the worry is because everything we do is opaque. Today, it's all wizardry, and nobody knows, right? So plant operators are worried that production quantities and product details can leak through telemetry to machine builders. The machine builder may be able to deduce how many cars you make and what kinds of cars you make. And the worry is not that the machine builder does something with it, but directly, but they go and tell the competition. Machine builders themselves are worried that performance indicators can leak into component suppliers, so the component suppliers can go and give their competition a tip for where that machine has its weaknesses. So everybody is worried. And in fact, if you take a look back at this picture, look around this show, look around what happens. There's equipment being offered that you can go and put attached to a component, go 5G, and then basically just smuggle telemetry out of the factory. I would be worried. I would not allow that. Or there's equipment that's being put on the machine so that the machine manufacturer can go and just get the data out. That is a way to make the component manufacturer happy. That is a way to make the plant operator worried, and ultimately introduce a policy that says no, because it's intransparent to them. So this is not a way how we can go and do all this. To add the bigger picture of the site, everybody will do cloud. And I think that's another trend you can see here, is that cloud is everywhere, because people have understood that putting IT metal on a site is not as good of an idea as putting IT metal into a cage in a data center with a fence and a moat and crocodiles around them. So security is a major factor in terms of making operations secure. There's another trend in terms of safety, which keeps a lot of equipment on premises, but there's more of a trend in terms of security, in terms of operational efficiency and cost to move things to the cloud, and everybody here offers you some form of cloud already. Some private, some public, but the trend is certainly from a cost perspective is going towards public cloud. And we have many clouds to look at. We have clouds for the product owners who actually make product and tell plants to make parts or complete products. And they want to see how their product flow is. We have operations and maintenance organizations. We have equipment makers. We have brand new digital services, which is kind of the unknown bucket, stuff that we don't even know what happens. There's another concept that you can see in all those booths here, which is about the digital twin, the cyber representation of physical objects. Everybody has those. So now you have one object, and there's a notion that is introduced, especially in platform Industry 4.0, there's a notion of a Verwaltungsschale, a management capsule, effectively, which is a physical representation of objects that are physical. And the current notion is that there's one for each object. If we follow that through, well then, everybody needs to talk to everybody. Because around the site, in cyberspace, all those federated systems which are being put together from components, that factory needs to be replicated over here in that cyberspace, but by the owners of the respective aspects. And then even more so, all of those folks also need to go and talk to each other. And when I say talk to each other, I mean literally systems integration between all of those, if you want to make this real. So we're not done yet. What we have done with OPC UA, which we can declare the winner, hands down, in the basic interoperability layer, is we have now created a way to take these physical systems and have them talk to the cyber, if you want to stick to the picture. But now the next frontier is, how do we make the cyber talk to each other? And that's what federation is all about. So federation is about integration of systems, and there's a lot of concerns and inhibitors. Concerns, trade secret disclosure, right? How many cars do I make? How many gears do I make? Does the company that makes the machines that I run this on, can they know? Employee privacy. People are working on those machines and are now being metered without you even wanting to, but you can derive that from the telemetry. Employee safety. Is it possible to go and send information from the cloud or from some other system to a physical machine that then goes and moves an arm while there's a person standing right next to it? Equipment safety, same thing. Product safety, ultimately, the thing that is being created needs to be safe, and that also needs to have a requisite quality. All of these are concerns that make ownership and distributed ownership and this federation really difficult. If we look at this picture of all of those different parties talking to each other, how do we even think about security? How does that work? How do we even think about securing? How do we think about identities of all those actors which are playing in this whole game? What protocols do we use? What data formats do we use? How do we think about semantics? Because we need to agree on the semantics and what a certain field means, right? You have a field that's called length. Is that meters? Or is that a wavelength? So you need to have more descriptive than just a field, a name, and a type. You actually need to have some details and semantics and context around all this information needs to be exchanged. And then, of course, a big thing that we're dealing with in the cloud, in our IT systems, is change dynamics. We literally deploy new software into living systems that don't stop every hour at scales, and while maintaining 5 nines of reliability. Right? We're still in OT, we're in a world where you shut down a line for 2 days to go and do an upgrade. That's not what you can do if you have these integrated global systems. You have to operate it all at super high reliability rates as we have in IT. So what we need to do is we need to go and do some work. And the work, a lot of that work is social first, right? Intercompany agreements, and basically just sitting down and making clear, here's what I want to share. And we start seeing that happening in conversations that we have and in conversations that we sit in, that there's now conversations happening about what is the benefit of me giving someone data, and then what is the trade-off that I make in terms of my corporate privacy and trade secret protection. And then if there's a compromise that I need to make, how much of a compromise do I need to make? So you need to establish clear contracts about which data can flow. Technical contracts, so these are basically just written down rules of literally this field, this field, this field, this field, in which precision. Be explicit about which data cannot flow ever. So what is the information that you cannot go and make available? Discuss information, which information can flow in degraded form, right? There's a lot of measurements which give you enough information to see whether a machine is healthy or not when you don't have the exact numbers, but you only have a degraded form of those numbers. So you don't know that something has the value of 5, but you can tell whether it's 0 or 10, or between 0 and 10, right? Just fuzz the data, make it less sharp, make it less precise, so you don't leak any valuable information, but still make it good enough to integrate. And then all of that needs to be governed with legal contracts that you can also enforce. And then you also need to enable, and this is the important thing, and this is one of the technical frontiers, is we need to enable verification. We need to enable a way to go and take that contract, take that agreement, and check it. Trust but verify. So check it, check the data that's going out, validate the policies that you've set, and then check that the data is compliant with it, and then flag if it's not. That requires that the data that's flowing through these systems, and I'm going to have a picture that illustrates it a little bit better, that data is secure yet transparent. You cannot hide. If you have a robot that sits on the bottom on the plant floor, and you have a cloud, a robot cloud, you cannot expect that all that data is going to be encrypted end to end. You can make it reasonably secure and signed so that you can verify its origin, the provenance as it's said, but you can't hide it from everybody because there's people on the way authorized to go and see it and potentially stop it because you need to enable verification. It should never have to be stopped, but it should be verified. Okay. So, technical view of this. The foundation is strong security foundation, strong hardware root of trust, federated identity mechanisms. All of these things are things that we are already addressing in OPC UA. Data provenance and integrity management is something that is not there yet. That's something that we need to go and discuss. How do we take a message and sign it in a way and encode it in a way that you can go and say, this is from this robot, but it's not encrypted, and it allows you to go and take data out of that package as you have a filtering mechanism on top, and still assure that it's from that robot. That's what data provenance is. Common protocols and data encodings. Establish agreement on semantics of information flowing in the system. Identify, delineate, and route data streams from and to machines and components. So data from one robot needs to go to the robot cloud. Data from one laser cutter needs to go to the laser cutter cloud. Understand, inspect, filter, and potentially fuzz data flow in and out of the facility. And then you also need to process that information in the end, in analytics, knowing that someone may have been intentionally degrading that information. So there's a lot of work, And very little of that is done today, and certainly not yet in the standards arena. So that's all just backlog work for us to deal with in the standards arena. So here's a progression in terms of where we are today and where we're going. So you have this is a pretty standard setup. You have cells with robots in them, and with all kinds of other equipments. And today, everything is, in many setups, everything is kind of straight networking. You do isolation of networks, you do VNets, you separate those things out, but it's all happening at the networking layer, right? So you have a firewall, and then you can get some TCP traffic in there, but you don't have a lot of control over things. Oops. And then you have site-to-site VPNs, where you're fusing networks, and now you're on this network, you're also on that network, which is also not a great security idea. So in super secure plants, you actually have this model, where you don't fuse the networks, but you effectively have messaging infrastructure that sits on the edges of those networks and looks into two networks with separate network cards. It's a broker that does that work, a message passing interface, and it's not fusing the networks. So now you have an application level abstraction between those things. So this is how, so if you now sit somewhere in that factory network, the only way you can get into that cell is sending a message to a broker. That makes things more secure. That also elevates all the communication up from the network level to the messaging level. And this is why we need protocols like AMQP and MQTT. This is why those protocols suddenly become relevant in this space, because if you elevate things up a level to messaging, you can build more secure and more flexible systems. What's going to happen next? So this is where we are, and this is where you see, if you see NetWIFC gateways around the show, right? These IoT gateways. These are little brokers. Right, they take messages in one protocol, they turn around and send it in the other way. And many of them also have two NICs, so they can go and look this way, they can look this way, and they provide the gateway between those environments. It's not one large network. It's actually it's cells that are insulated and where the integration happens through message passing. As we go down here we go. As we go further, you will now see the IT systems starting to creep down into the production environments. And this is something that will happen. Creep down is kind of from the nervous perspective. Fog and edge. It's also terms you can already see at the show here. Provide ways to run general purpose compute work inside of networks, inside of infrastructures. So effectively, an IT system that does analytics up in the cloud can now send data, can send delegates in terms of little computicles, functions, can send them down and can run them here on this machine or can run them somewhere in the network to make sure that you can tune the telemetry stream and can send only the data that's relevant in the cloud and don't have to deal with all of it and don't need to send terabytes. But the fog and edge model is where now functionality trickles down from the cloud, so to speak, into the production environments, and that's something that will be a trend that you will see develop in the next HANNOVER MESSE and the one thereafter. In the next 3-4 years, fog and edge are going to be very, very large story, and that's something that we already foreshadow in some of the announcements that we've made for Microsoft. Data needs to be encoded in agreeable ways. We need to have common understanding. One of the reasons why we chose a protocol or an encoding like JSON for OPC UA is that it's widely understood by the IT tools. So we don't use the super efficient bit-by-bit protocol encodings, but we use the ones that are used by and easily understood by everybody who's working with these modern analytics infrastructures. So that's a choice that's being made just to bridge that OT-IT divide. And then lastly, we need to have common understanding of semantics, as I said. There's a huge field that's open. There's some work that has started in Platform Industry 4.0 around common semantics for data. And eventually, we need to have catalog system, catalog infrastructure that allows everybody to go and share those semantics information so we can go and understand each other. So, we've done, there's reason to celebrate because OPC UA is a great step in the right direction. I think where we are today with a release candidate that's going to be soon finalized, and with all the work that you've seen the industry do with all of that, we have reached a great point where we say, yeah, we've achieved something, and there's a lot of work left to do for us. And the systems federation, the integration challenge in OT is going to be vastly more complicated than anything we've seen in IT so far. And so you're all catching up very, very rapidly to where we are in IT. This is great. But there's a lot of work ahead, and I'm certainly looking forward to being part of that. Thank you very much.